Alright, so today I'm doing a Kakuro, and the rules are very simple, right? So we have to place the digits from 1 to 9 in this grid, and the small numbers in the triangles show the sum of the numbers in that row or column. So for example, the 4 digits here in this row has to add up to 16, and these 3 digits has to add up to 12, right? And the same digit cannot repeat on a row or column. So this that cannot be 2 9s like this, for example. Yes, so that's pretty much the rules. So I'm just going to start to solve this now. All right. So first off, I'm seeing this 16 sum, right? And the only way you can add 16 in this puzzle is with 9 and 7, because you cannot use 2 8s. That's against the rules, like this. And already we could see here that this cannot be 9, because then you cannot have a sum to 8 here. So this means that this is a 7 and this is a 9 and this is a 1. All right, and here also you can only have the digits 1 and 3 are the only digits that sum to 4 in this game, and we can see that 1 cannot be here, so 1 has to be here, 3 has to be there, and 6 has to be here, and 5 has to be here. All right, and yes, so 10 is actually the smallest sum you can have with 4 digits in this game, which is 1, 2, and 3, and 4. So yeah, but yeah, so the digits 1, 2, 3, and 4 has to be here. I don't know if I'm going to note this. I might. Okay, so 1 and 3 cannot be here. 2 and 4. 1 cannot be here, because then this would be a 10. Likewise, 3 cannot be here, because then there would be 2 3s. And 3 cannot be here, because the only way to sum 7 with 3 digits in this puzzle is with 1, 2, and 4. Oh, sorry. And 4 cannot be here, because we have to sum to 3. But this cannot be 2. This cannot be 1. Sorry. So this is 2 and this is 1. So this has to be 4, right? And then that means this cannot be 4. This cannot be 1 as well. So this is 2. This means this is 4, and yeah, because this cannot be 2 and 4 and 1. This has to be 3, and this has to be 1, right? So this has to be 5, and this has to be 8. All right. So what do we have here? We have 17. So we are missing 6. All right. Then what numbers are we missing here? We have 1. The numbers 1 through 6. So and this has to sum to 38. So one small trick I will tell you in Kakuros is when you have a long sequence of a long sum, right? For example, here we have 8 digits that has to add up to 38. When you have this, it's important to remember that the digits 1 to 9 they sum to 45, right? So you can imagine if you line them up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then take a digit out, right? Let's say you take 5 out. Then the rest of the digits will now add up to 40, right? Because you took 5 out. Now imagine the same thing. Imagine that we have done the same thing with this sequence. Imagine that we had a 9-digit sequence, and that we took one number out here. This is the exact same thing. And what number have we taken out so that the sum has to be 38? Well, that number is 7, right? Because 45 minus 38 is 7. So that means that 7 cannot exist on this column of numbers, which means that the numbers that we are missing are 9 and 8. So a 9 cannot be here. So this is 9 and this is 8. I hope that made sense. Alright, this means that this is 1 and this is 7 and this is 4. We have 1, 2, 3, 4 here. 4 cannot be here, 4 cannot be here. So we have to have, 4 has to be there. So that means 8 has to be here. Okay, let's see, 12, 7, 1, 2. Okay. Now this is 3 and 1. 3 cannot be here, so this is 1, 3. This has to be 1. Now 2 cannot be here, so this has to be 4. This has to be 2. This has to be 8. This has to be 3. Now the only ways of having a 2-digit sum that sum to 5 is by through the digits 1, 4 and 2, 3, and you'll see that in any case, whatever this is, right? No, sorry, you can see that it cannot be 2, 3, right? Precisely because that how are you going to place 2, 3 when 2 and 3 is here, right? So it has to be 1, 4. So this is 1, this is 4, this is 2, this is 5. And again, let's try to use this logic from before. Okay, again, we have 8 digits. That means that what digits have we taken away from this 9-digit sequence so that the sum now is 37? Well, that is of course 8, right? That means 8 cannot and does not exist on this column. Which means, because 17, the only way you can add up, okay, you can get 17 in this game with 2 digits is 9 and 8, so we know that 8 cannot exist on this column, so this is 8, this is 9, this is 8. And we have 4 here, which means these two are 1, 3, 1, 3. And let's see, what do we have left here? We have 1, 2, 3, 4, 5, so we are missing a 6 and a 7. Okay, please stop. A 6 and a 7, okay. Right. Yeah, 6 and a 7. Okay, I've said that too many times. Anyways, now look at this sum, okay? 26. Yeah, if this cell is 3, right? Now, if this cell is 1, then that would leave us with 25 as the sum of these 3 digits. But you cannot actually have a 3-digit sum where you can, the highest sum you can have, is with 3 digits is 24, right? 987. So this cannot actually be 1. This means this has to be 3. 3. This has to be 1. And now this means that these 3 cells has to add up to 23. And the only way you can add up 23 is 9, 8, and 6 in this game without repeats. So this means this cannot be 7. This has to be 6 and 7. Okay. And yeah, what do we have left here? We have to add a 9 and an 8 in these 2 boxes. Well, 9 cannot be here because then this would be 1, and we already have a 1 on that row. This is 8, this is 2, this is 9, and this is 6, and that is it, right? Anyways, I hope you enjoyed this video, and yeah, that's it.